Hey everyone, in this video we are going to discuss building an API using the Django Python library. To build any kind of application, the users using their PC or smartphone device, which we'll call from now on the client side, will need to send requests to the database and get information. But there are many kinds of requests. So the API, or Application Programming Interface, will handle the requests and query only the relevant information from the database, or write the info into it. Then the API will send the information as a response back to the client. There are many ways to build an API, but doing this with Django is a great idea if you already know Python, since it's a Python library. It's easy to learn the basics of, and many features are already implemented for you, saving you time developing. And since it exists for such a long time, by now it has a lot of options and tools and an active community to get help from. In this tutorial, I will take you through building an API that can serve a gym workout app, where users can pick a gym and schedule a workout of any type. To start a new project in Django, I simply open a new folder with the app's name, and I'll call this one Jimmy. Then I open this folder in VS Code. Use the version command to make sure your Python version is up to date, or at least 3.7, and install pipenv, the best way to manage a virtual environment. Move to the projects folder and install Django using pipenv. This will create a new virtual environment and install Django within it. To activate the newly created venv, which is virtual environment, use pipenv shell. Go back to the projects folder and create a new folder within it. Here I call this folder core, but you can give it any name you like. Note the dot at the end. If you won't use the dot, you will get duplicate folders, as Django will think it needs to create a general folder for the project. Now, let's go through the structure of our newborn project so far. The core project will contain files that will be, well, the core of your API. We will go over some of them in a second. The manage.py file, next to the core folder, will allow us to run project-specific commands. We will see examples soon. Within the core folder, there are 5 files. They are all important, but I'll go only over the ones you need to get to know now. The settings.py file contains the general settings for the API, and we will need to modify it many times. And the urls.py file is responsible for directing the requests clients make from any specific URL to the correct request handler. More on that in a bit. To better understand this, let's go through an example. Let's say a client sends a request to get all of the data on customers that are named Ben. The request is sent to the URL jimmy/customers, and it is routed to a request handler that will query the database for all of the customers that are named Ben. The data goes back to the request handler, which sends it back to the client as a response. In the Django terminology, a request handler is called a view. Back to the project creation process, the final step is to run the run server command, which will create a local development server to test your project on. Ignore the warnings for now and go to the URL that Django provides. If you see this, then your project was successfully created and we can start expanding it. Now, we need to understand one of the most fundamental concepts in Django: apps. Not apps like these that you can run on your mobile device, but internal Django apps, the reusable building blocks of your project. Each of them is a standalone piece of code that you can add to the project from an external source or build from scratch. Each has a unique role, and if you open settings.py in the core folder, you will see the list of apps that are provided to you by default from Django. Not all of them matter to us in this tutorial, but we will get to know some of them along the way and add new ones to this list. We need to create a new app to handle the entities that are unique to our project: a gym workout scheduling app. A full production scale project might be divided into several new apps. Maybe one for different gyms, one for the workouts, and one for the reviews on the gyms and trainers. But we are going to keep things simple and create one app to rule them all. So you need the command start app, followed by the app name, and register this new app in the list of apps in settings.py, so that Django will recognize it. A new folder will appear for this app. Note that we are also getting a SQLite database for development. Remember that you need to replace it with a production-grade database like Postgres before deployment. Within the apps folder, there are several files we need to get to know. Migrations are Django's way to update the database according to our app. We will learn to use them very soon. apps.py is a misleading name. This file contains app-specific configurations and settings. Models are representations of database tables, so if you build a model of a gym with fields such as name, address, and phone number, by applying a migration, Django will automatically create a database table called gym with matching fields, without you ever having to touch the database yourself or write SQL code. This makes life way easier. Finally, the views.py file will contain the views for this app. Remember that we talked about views? They handle the requests from clients. Now it's time to write our first model. Go to the models.py file and define a class called gym that inherits from Django's general model class. With Django models, the ID field is created automatically and there is no need to specify it. Add a name field, or of type char field, which is designed for short texts. The max length is a required argument. We will get to know some types of fields and possible arguments, but there are many more available. Check the docs to learn more. Add a description, address, and phone fields, each with appropriate field type, which Django will convert to matching database fields under the hood for us. Default is an optional argument that can go into any field definition to set the default value. With the AutoNow set to true on datetime field, this field will be updated automatically whenever this model is updated with the current date and time, so we can know when it was lastly changed. And similarly, with the AutoNowAdd argument, the time of creation will be recorded and won't be changed ever. Now we need to migrate this new model into the database. Use the make migrations command, followed by the migrate command. Now the gym table appears in the database. Now we can create our very first view. But before we do, since we are interested in building an API, we better do some further installations that will help us with that. First, install the Django Restful API library. I will soon explain what a Restful API is. Then, add it to the installed apps in settings.py. Now, register a superuser so that we can add custom data later on as admins. Now go to the admin panel using the super user account you have just registered. Log in into the admin panel, and in the admin.py file, import the models file, and register your models so that the admin panel will recognize it. Now refresh the admin panel and you will see the GEMS model appear in it. Add a single made-up gem to the database just for testing. We will delete it later. Now we need a serializer to use with the view we will create. When the view queries data from the database, it stores it as a query set if it's multiple items or a single object, which are forms that Django can work with, but the client can't. The serializer's role is to take this information and convert it to a form the client side can understand, such as a JSON object. To build a serializer, create a new app file called serializers.py, and in it import the Serializers module. Define a gem serializer class that inherits from the base serializer class and simply define the fields you want to send to the client. You don't have to use all of the fields in the model. For example, date created is for your own private use. Now we can finally define our first view. In the apps.views.py file, import a bunch of things I'll explain as we use them. Use the API view decorator that will give us a testing interface we will soon see, and will make the view compatible with other REST framework features. Then, define the view function for the gem model. The detail term here is a Django convention, which means this view handles requests that ask for data on specific gem, in contrast to asking for a list of them. The view takes two arguments, the client's request and the ID of the gem information for is needed. Now we need to get the gem object from the database. The get object or 404 will return a 404 HTTP error, object not found, if the gem the client is asking for does not exist in the database. If it does exist, the function will retrieve it. We give this function the gem model and the ID of the gem the client is asking for. PK simply means primary key, the ID field, here. I assume you know what primary key means, but if you don't, pause and Google it. Then we use the serializer we built to convert the gem object into JSON and return the data in the response to the client. The last thing left to do is to take care of the URL routing. First, go to the core urls.py file. Make sure you have both the path and include commands imported. Now add a new URL path that will route all requests to the app we are building. And use the include command to route all such requests to the app-specific urls.py file. By the way, create an app-specific urls.py file. Within it, import the path command and the app's views. Add a URL patterns list and create a new path. Call the path gems/id and add the int annotation so Django will only accept from the client integer IDs. Tell Django that requests with this pattern should be handled by the gem detail view. Let's recap on what just happened. Now, when the client sends a request to this address, the include statement in the core urls.py file routes the request to the app's urls.py file, in which it matches the gems/id pattern and is sent to the appropriate view. Great, we are all set. Now just go to the address we just defined and you will get to the REST framework testing page. You can see the fields we defined in the serializer and other details on the request, like the 200 HTTP response that means everything went well. Specifically, I want to discuss this GET word that is written here, and more generally, RESTful APIs. Don't be confused by the name. There is nothing particularly RESTfulnessy about them. RESTful APIs are APIs that are governed by a specific set of rules and conventions. It's a complicated subject, so I'll cover the only aspect of it that is currently relevant for us. HTTP methods, which tell the API what kind of request is it. They are included within the request. Some common examples are GET for retrieving information from the database, POST for saving new entry in the database table. For example, when signing up as new users and sending the user details to the database to be saved in the users table. PUT for updating all of the fields of an existing database entry, updating all of the fields of a certain gem, for example. And patch for updating only certain fields, like changing only the name of a gem. Oh, and there's also delete for deleting stuff. Now it's time to define another of Django's conventional views, the list view, which lists all of the objects of a certain type. In the views.py file, define a list view function. It should take only the request as an argument. No need for an ID, since all gems will be returned. Now, use the gem model's object manager. Through it, you can query any subset of gems you are interested in. For now, just use the all method to get all gems. Serialize their data, and since there is more than a single gem, use the many argument to let Django know that it needs to parse multiple objects. Now return the data as a response. Go to the gem's URL without specifying an ID, and you will see a list of all gems. We currently have only one in our database, but had we had more, we would have seen them all. Of course, our project needs more tables than just a list of gems. It needs user profiles, types of activities like CrossFit, yoga, and Pilates, and specific workouts at the various gyms. I will now create these models and explain only new concepts that were not presented when we created the G model. Here is the profile model. Most fields here are self-explanatory, but I want to explain this status field. Let's say that there are two types of users, those on a trial subscription and regulars. I want to limit this field to only these two options, so I use the char field with max length of 1, and the choices argument to limit the field to only the options I specify in the options variable. The list of options specify the letters and their meanings. The default option is specified above, so if I ever want to change it, I need to change it only in a single variable instead of two in options and in the default argument in the status field. The activity model has nothing new, simply a name and a description. In the workout model, though, we have something new: relations to other models. The idea is that each workout has a gym and an activity associated with it, and those fields will contain their IDs. So, for example, a workout at Wednesday night can be at the gym with ID 513, and the activity in this workout is activity 2. The argument to these fields is the name of the associated model, gym and activity here. By the way, Django will automatically add a reverse relation field to the gym and activity models. By default, these fields will be called workout set. They will simply be another field in the related object. Now, the foreign key fields require another argument, which tells Django what to do with a workout whose gym or activity has been deleted. Here, if an activity is deleted, its workout will have a null value in this field, to give the gym a chance to replace the activity. That's why I also allow this field to be null. On the other hand, if the gym itself is deleted, I want all of its workouts to be deleted as well, automatically, which is what the cascade option does. Finally, I add the profile field that will connect a workout to its users. It's a many-to-many relation, since each workout has many users, but any user can be registered to several workouts. This will automatically create a reverse relation field to the profile model called workout set. Remember to migrate your models and apply them in the admin table like we did for the gym model. Also, add some made-up data in the admin table for experimentation. Now, before moving on, let's talk about Django's ORM. We have seen it in action before with the code snippet in the gym list view, when we got all of the gyms in the database as a Django query set. From the model, we got to its object manager, and we got all of the gym object as a collection called query set. You can also get a single object using its primary key, which is usually the ID field. Methods can retrieve query sets, single objects, or integers. Usually, it's easy to tell by what the method is. Now, if you get a query set, it is not yet a list of single objects. Django is using lazy evaluation, which means the query set is only a set of instructions for the querying the database. Django will not actually do it until it has to. This allows for better optimization since it gets to know instructions that are ahead in the code and planned accordingly. To get it to actually pull from the database and retrieve a list of objects, you need to either iterate over it, convert it to a list, or index it. By the way, the result is stored in a cache, so if you retrieve it twice, say listing it and then indexing it, the index operation will not create another database query. I'm going to run down the list of the most fundamental ORM options now. Don't try to memorize the syntax. Just get a feel for what's possible and come back here to check the syntax when you need it. You can count how many objects you've got and get back an integer. Filter by a field and get back a query set. GT stands for greater than. There are variations for all other logical operators. You can filter by a range. Note the double underscore. Filter by matching a list. And filter by fields of a related object. And many more. Use the distinct method for getting back only unique objects, and contain for matching a string. Again, don't forget the double underscore. You can filter by several fields, and make complex queries using queue objects that allows you to be able to use the OR operator, the AND operator, and the reverse operator that returns only objects that do not meet the condition. You can sort objects by several fields, change the ascending default ordering to descending, index results like a normal Python list, and select only specific fields to query. You can select related objects using the selectRelated command. If you try to get them without this command, Django will act weird and create a different SQL query for each entry. Can also get a single field of that related object. But if for each query there can be several related objects as opposed to a single one, for example, if the entry is a workout and there are several users that participate in it, use the prefetch related method instead. You can also aggregate results and get back an integer. Now, let's look at this code snippet. We can use the annotate method to create new fields that are not included in the model. Here, we define the new field's name. We use the func function to use a database function, such as concat for concatenating strings together. The f object allows us to pass fields as arguments for a function, and the value function allows us to pass a string, a number, or a true-false boolean as a function argument. Wow, I'm glad we got that out of the way. Now, building the workout serializer and its view afterwards will let us learn some additional useful stuff and practice some of what we know. Here we are going to learn about a new kind of serializer, the model serializer. It has the same purpose as the basic one, but saves you time writing code. Inside an inner class called meta for specifying the metadata of the serializer, define the model the serializer will serialize, and the fields of that model that you want to serialize. If you have a related object in that list, you will have to manually provide a serializer for that related object as well. It can be the regular serializer for that model, or a unique one that you defined for this use case. Here I created a specific serializer for the activity model, for the fields I want presented inside the workout. Similarly, I created a custom serializer for the profile, but since any workout can have many profiles connected, I had to use the many equals true statement. Model serializer should be your default serializer, so as an exercise, convert the basic gym serializer into a model serializer. Now to build the view. It's going to be a list view, just like the one I created for the gyms, except that we are going to add a filtering that will include only workouts that has at least a single user registered to it. We start by creating a custom field that contains the number of users in each workout. The annotate field creates a custom field that will be called num_participants. That will contain the count of profiles by their ID field. Then I filter so that this count field is greater than 0. Now, let's talk about allowing clients to send new data to the database using the post-HTTP method. For example, creating a new gym. Serializers work in the reverse way as well, taking JSON data or other formats from users and converting it to a query set or Django objects. First, we have to split our gym serializer into a serializer for GET requests and another one for POST requests. The reason for this is that the GET serializer contains only the fields that we want clients to see when they pull data on gyms, but gyms have more fields that needs a value at creation. Therefore, in the POST serializer, we need to contain all of the fields that needs a value from the client. Date added, for example, is updated by itself, so as the ID field. Remember to replace the old serializer with the new GET one whenever it's needed. Now let's update the view to support post requests. The API view decorator accepts the methods we want to support. We didn't specify them before since get is the default. The post method should be connected to the list view, not the detail view. That's because the detail view accepts an ID, but we don't have one when we create a new object. We need to assign it a new ID. If the method of the request is get, we just use the code from before. But if it's a post request, we use the post gem serializer with data from the request and make sure the data is valid. If not, Django automatically raises the appropriate HTTP error, 400, which means bad request. We save the data into a new object in the database, and it's customary to return the details of the created object back to the client as part of the response, along with the success HTTP code 201. Now, just go to the gems URL and paste a new gems detail as a valid JSON below and hit post. If everything went well, you will get a 201 response and the details of the gem back to you. The delete method will be the last HTTP method I cover, but it shouldn't be too hard to figure out the put and patch methods using Google and the docs. They are not that different. This time we add the delete method to the decorator and modify the gem detail view, since it gets the ID of the gem we need to delete. We retrieve the gem whose ID we got from the request. If the request HTTP method is get, we use the same code as before. But if it's delete, we apply the delete method. Very simple. Only thing left to do is to return an empty response with the 204 HTTP code, which means no content. Now go to the URL of a specific gem, say the one with ID 4, and press the delete button. You should get the response we just defined. Now, all of the views we defined so far were function-based views, which are easy to understand. But to unlock Django's REST framework's full power, we should switch gears and move to class-based views. Now, before we convert our workout list view into a class-based view, we need to divide its serializer into two, one for reading data and one for writing it, just like we did with the gems. The workout serializer read is what we had as the regular serializer until now, just with a different name. But the workout serializer write is different. For all three related objects, we use the primary key related field, which means that when the client specifies to which, for example, gem, the workout belongs, they only have to provide the ID, which is the primary key of the gem. For example, if this is the data the client sends for the new workout it is creating, it only needs to provide the IDs for the gem, activity, and profiles of users in this workout, instead of a whole object. Now, to convert a function view into a class, import the API view base class, and let the workout list view to inherit from it. Then, define the get method. Feel free to add any filtering, like the one we had before that filters out empty workouts, if you want to. Remember to input the self argument, since this is a Python class, and preload all related objects, so that Django won't have to execute a distinct SQL query for each related object separately. If you don't provide any fields, these methods preload all of the related objects fields. Then, in the same way, define the post method. Just remember to use the serializer for writing instead of the one for reading here. To save ourselves more time, we can use something called GenericViews that do for us common tasks like implementing a view for listing objects and adding new ones. It makes sense because the code for these generally always looks the same, with slight variations. Start by importing the ListCreate API view base class. There are other combinations except listing and creating, so check the docs to see what fits your use case. Define the generic view and inherit the base class. Each generic view needs to get a query set, so we provide it. It also needs a serializer. If we had only one for reading and for writing, we could have provided it as an attribute, just like with the query set. But since we have two, we need to override the method for getting the serializer and implement our own logic. So, if the method is a get method, we use the serializer for reading, and if not, the one for writing. And that's it. That's the whole view. Much shorter and easier to maintain. But what if you want to take care of all of the methods in the single view? That is, to combine the workout list view and the workout detail view into a single view to save time and make life simpler. On the surface, the code is almost identical to generic view, and that's because a ViewSet is basically, but not completely, just a very general generic view. The difference is just the base class, which is the model set view here. And the result is that now both the list workout endpoint is implemented, where you can get a list of all workouts and create a new one, and the detail endpoint, where you can get all the details on a specific workout, update it, and delete it. Except that you can't yet. There is now an issue with the URL routing. You have two endpoints with a single view, and to account for it, we need to use a router. In Django, a router is a tool that helps us automate complicated URL into views mapping. Simply define a router and register the workouts endpoint, mapping it into the workout view set. In the URL patterns list, add a path from an empty string to all URLs included in the router, which will be both the list and details patterns for workouts. Now both endpoints would be working. Now, what if we want to add some special logic to the view set? For example, that you cannot delete a workout that has users registered to it. To do that, we need to override the relevant method, the destroy class method, which takes care of the HTTP delete method. You can learn that from the documentation for ViewSets. So I define another class method within the ViewSet called destroy that accepts self, request, and PK for primary key, just like in the docs. I get the object to be deleted and check if it has user profiles connected, which is simple to do since there is only a single object. If it has user profiles, we return a response with an error to the client, which will look like this. But if it does have 0 users connected, we delete it and respond with the 204 HTTP response. Okay, but what if we want to get all of the workouts for a specific gym? We need an endpoint for that. That will look like this. First, a gym is specified, and then the fact we want its workouts. Well, for that, we are going to need the DRF nested routers library, where DRF stands for Django REST Framework. Then, replace your function gym view with a class view if you haven't already, since this will not work with a function-based view. This should be simple enough for you to do so by yourself, but this is how I've done it if you want to pause and take a look. Now, we need to set the nested routers. First, import routers from REST Framework Nested. Create a simple router, and register the workouts and gyms endpoints with their ViewSets. The base name is required whenever you register the same view twice, and since we are going to use the workouts ViewSets both on its own to get all of the workouts, and to get the workouts for a specific gym, we are going to need it. Remember that a ViewSet takes care of both the detail view and list view under the hood. So to reference them in the code, it automatically generates names for them. With gyms, for example, it will be gym list and gym detail, but that breaks when we have workouts registered 2 times, since Django can't name both cases the same way. So the base name allows us to specify the prefix for the words list and detail for each time we register this ViewSet. It's just for internal use, though the URL themselves won't be affected. Anyway, you need to define a nested simple router and provide it with the parent router, name of the parent URL name from the parent router, and a lookup, which will be the prefix for the parent primary key variable that will be available later in the workout ViewSet. I'll indicate it again later. Now, we register the new endpoint in the same way. Since the base name is gym workouts, the internal names for the list and detail views will be gym workouts list and gym workouts detail. Unite the 2 lists of URLs from the 2 routers into the URL patterns variable. When you do it like this, you don't need the path command. Only thing left to do is to modify the workouts ViewSet to handle the new functionality. Specifically, we need to take care of the way the view retrieves a query set. Now, it always returns all of the workouts, regardless of if we constrain it to a single gym or not. To take care of that, replace this line with a function for getting the query set of workouts. The name of the function is important, so don't typo. The idea is to have a different query set depending on the URL. If it's the general workouts endpoint, we filter like we did before and retrieve all workouts. But if it's the gym-specific endpoint, we have to filter the workouts to those where the gym foreign key matches the gym PK variable. The prefix gym comes from the lookup field we provided in the nested router. Okay, but what if we want clients to have the option to ask for a specific filtering within the URL of an endpoint? Maybe something like specifying that we want only Pilates workouts. Well, like most things in programming, there are several ways to achieve this, but a good one is to install the Django filter library and add the app to the list of installed apps in settings.py. Note that it's called differently here than its pip installation name. Also, create a filters.py file in your app. In filters.py, import filter set and the model you would like to filter. Define the workout filter class, inherit the imported based class of filter set, and define an inner class called meta. Define the model you want to filter, and create a dictionary that will contain the fields we want to filter by and which filters can be applied to them. The keys are the filters you want to filter by. Here, I show you how to filter by a related object. You prefix with the field that holds the foreign key, use double underscore and the field of the related object to filter by. If you want a simple regular field, just write its name as it is. And then, in a list, specify what filters can be used with this field. Here, the only one I want is exact match, but you can look at the docs for all of the possible options. In the ViewSets, we need to add several lines. Import the Django filter backend and the filter you created from filters.py. Then add two properties to the class, the backend and the filter set. And that's it. Now, clients are able to filter workouts by activity type. Another common filtering task is searching within a text field. Description, for example. With Django, it's extremely easy. First, import the search filter. Now, within the view, expand the filter backends to include the search filter. And specify the fields to search in. Again, I show you how to include a field from a related object, but if you want a simple field, just write its name as is. Now, if the client wants to search, he can. And he will get CrossFit workouts, since their description in my database is, we don't use machines, we make them. Another thing you might want to do is to let clients sort the results by a certain field. Then, just like with searching, add the filter to the backends and specify the fields. Now, clients can sort using the URL like this. They can specify which fields to sort by, and use a hyphen to reverse the sorting order. To have the Django API divide the results set into pages, simply import the page number pagination backend, define a pagination class and inherit the base class, and specify the number of results per page. Then, add the pagination class to the ViewSet. Okay guys, thank you so much for listening. I estimate we covered around 50% of the subjects needed for creating a production-ready API with Django, but there is much remained to explain. Security, replacing light SQL with production-grade database, testing, handling files, the process of deployment, and more. Let me know in the comments if you want another video like this one, where I'll explain all of those. Meanwhile, hope you had fun learning and I'll see you soon with more exciting videos.